So let's start our day. That few questions are remaining and I received the solutions by others. So we are just discussing. Discussing means I am going to discuss, not from you, or otherwise it will take more time. And so I think simple structure of solution we can have. So here is the question that what is the angle between the bisectors of both angles in linear pair? It is a simple kind of question. I will give you the idea that how we worked over here. Not exact solution, but okay, we are just verifying that what you have worked, whether it is correct or not. Moreover, again, I tell you that there can be more than one ways for some problems. So if you have, it's okay that you are having additional part. But now I think because of the less time, um, I'm not going to entertain immediate the solutions because it will take some time. If a critical problem comes or some variety of solutions are there, then we will discuss. This is a straightaway question that what is the angle between the bisectors of both angles in linear pair. For that, we must understand what do we mean by angles in linear pair. So here I can give you a brief idea that um, two angles which are adjacent as well as supplementary. So that is a definition of angles in linear pair. Two angles which are adjacent as well as supplementary. So we have to consider, suppose this is line AB, say here is point O, then I may draw ray OC, then angle AOC and angle BOC are supplementary or angles in linear pair, are angles in linear pair. So we bisect them, bisector that is making two equal angles. So these are the bisectors. Suppose ray OP bisects angle AOC and ray OQ bisects angle BOC. Then we need to find out angle POQ. Okay. So we say here that ray OP bisects angle AOC and ray OQ bisects angle BOC. Okay. When we say bisect, that is making two equal parts. And then therefore, if I say that, or we can say let angle AOC is 2x and angle BOC is 2y. So we consider that angle AOC and angle BOC as 2x, 2y. And because they are linear pair, we know that angle AOC plus angle BOC is 180 degree. And then therefore we have 2x plus 2y as 180 degree. We can divide both sides by 2. So we get x plus y as 90 degree. Because ray OP bisects angle AOC and ray OQ bisects angle BOC, so we have angle AOP equal to angle POC as x as well as angle BOQ is equal to angle QOC as y. So typically we choose angle x as angle POC and angle y as angle QOY, and we suppose it as number 1. Then we can say from 1 that angle POC plus angle QOC is 90 degree. But when we observe here, then we come to know that POC and QOC, they are adjacent angles. So by angle addition axiom, we say that angle POQ is their sum, which is 90 degree, which is need to find what is the angle between the bisectors of our both angles in linear pair. And we did this with justification. This is a common way and many of us have sent me the solution. So I am little bit faster. Okay. So I may turn the slide and I consider that you are writing along with me. Yes, Bhairav?
Sir, are we supposed to send the solutions?
Yeah, if these questions are not that much harder, if you have any doubt or if you are in dilemma whether your solution is correct or not, then you can discuss with me through the mail. And I think Ritvik sent me that and I went through. I didn't reply immediately because you have solved correctly. If there is a problem, then I may give you the hints or some suggestions. And if my suggestions won't come, then you consider that you are doing good. Okay. So it is
Okay.
not necessary that exactly you need to send the solutions always. Okay. But if I ask that I want solution of this and this question, then you need to note in your notebook and you need to continue for that. Okay.
Okay.
Yeah.
Thank you.
Yeah. So I hope I cleared the point. Yeah. Raksha, what you have? Sorry, Rakshaya. I'm wrong. Hmm.
Yeah, I don't understand the part that you, how did you consider that angle POQ is equal to 90?
Okay. What I didn't get you. Can you repeat? Hmm.
That you concluded the angle POQ equal to 90 also.
Okay. Okay. Do you know what adjacent angles are?
Yes.
Adjacent angles, that is, they have the common origin, that is vertex, one side common and different interiors. So here angle POC and angle QOC. If you see in the figure that angle POC and angle QOC are uh, adjacent angles because they have common vertex O, they have common side OC, and their interiors are different. So they are adjacent. If adjacent angles are there, then their summation, that is POC and QOC together form this angle POQ. And so we concluded here as POC plus QOC as POQ. Got it?
Okay.
Okay. Yes. Yeah, Dhruva. Sorry, Druhi. I'm wrong.
Sir, will these slides be posted in the classroom?
I think not because I didn't send the PDF. If you want, I can send the PDF. No worry about that. Okay.
Yes, sir.
Yeah.
Thank you.
Okay. Yeah. So going ahead. Then there is next question that to show vertically opposite angles are equal. First thing is that we must know what are vertically opposite angles. Again, this is a pair of angles when two different lines intersect each other intersect each other, then a pair of non-adjacent angles is termed as vertically opposite angles. We may define these vertically opposite angles like two different lines intersect each other, then a pair of non-adjacent angles is the vertically opposite angles. It's a pair, that is two angles together. Okay, and we also can define it as when both rays of two angles are pairwise opposite rays, then they are vertically opposite angles. When two lines intersect each other, suppose I consider that line AB and lines PQ intersect each other at O, then non-adjacent angles. Because if you see here, angle AOQ and angle BOQ are adjacent. Moreover, angle BOQ and angle BOP are adjacent. But according to the definition, we want non-adjacent. So there comes AOP. Then AOP and angle BOQ are vertically opposite angles. Simultaneously, we have another pair, that is angle AOQ and angle BOQ are vertically opposite angles. So for writing the solution, we are writing the proof, we consider the figure. And yes, you have to write along with me. That is always a better idea for us. I may continue the same names. So here we say that lines AB and PQ intersect at O as shown. Then we need to show that, or to prove that, angle AOP is equal to angle BOQ and angle AOQ is equal to angle BOP. When two lines intersect, we get two pairs of vertically opposite angles. Both are of the same case, vertically opposite angles. So if we show any one of them are equal, then that symmetrically or similarly we can say for the second pair. So our proof goes like angle AOQ plus angle BOQ is 180 degree. The reason is angles in linear pair. Angles in linear pair. You can see in the figure where are these angles are. Angle AOQ and angle BOQ. They are in linear pair. Also, we have angle AOP plus angle AOQ as linear pair. So both have the same reason. So I make the common bracket for them. So it saves our time. So there are two pairs of angles in linear pair I consider. Actually, there are more because one is along AB like AOQ, BOQ and AOQ, BOP. Also, there is AOP and BOP, BOP and BOQ like that. Okay. So after this, we say that because either we equate these both equations. Which are the equations? That angle AOQ plus angle BOQ is 180 degree and angle AOP plus angle AOQ is 180 degree. Both have RHS as 180 degree. So we can equate them by transitivity. Or we can subtract them, also valid. Either we equate or subtract. Both things are the same, equivalent. Okay. So I use by transitivity. Transitivity of equality means what? That I am writing at the right down corner. Suppose x is equal to y and y is equal to z. So I consider x is equal to z. So first is equal to second. Second is equal to third. So first is equal to third. That we term it as transitivity for equality. Or here I only stated transitivity. So these 180 degree are the same. So I have angle AOQ plus angle BOQ is equal to angle AOP plus angle AOQ. It's just like what we say, a simple equation. That equality is there. So we find that AOQ are the same on the both sides. So we subtracting angle AOQ from both sides. When we subtract these angle AOQ, I will write direct result. We get angle BOQ is equal to angle AOP. So what is our first part? AOP is equal to BOQ. Those two angles are equal. We proved, and then we needed to write similarly we have angle AOQ is equal to angle BOP. It completes the proof. Okay. So again, we no need to do the whole stuff like what we had, the two equalities, then we use the transitivity or we subtract them. So we get this equality. Similarly, for these two, we need to consider AOP plus BOP and AOQ plus AOP, so that AOP OP get cancelled and we get the same. So it is the same structure, same way. So we write similarly and we complete the proof. So we make a box. That box shows completion of the proof. Many times in many good books, such boxes are used. Yes, Arnika?
Sir, while like defining the vertically opposite angles, you
Hmm.
said that they were non-adjacent angles. So like what exactly could we define adjacent angles as?
Okay, so I think I have to write over here because there is no space. I can write the definition of that. If two angles have same vertex, one common arm, but different interiors, then they are termed as adjacent angles. So there are three conditions: same vertex, one common arm, and different interiors. So here I can show you one figure. Suppose in this figure, say there are three angles in all: angle POQ, angle QOR, and angle POR. These three angles are there. This is O. Then we consider the POQ, QOR, and POR. If I consider POQ and POR, okay, if I consider POQ and POR, then we find that POQ and POR have same vertex O. Okay, POQ, POR have same vertex O, or otherwise I can do like here. Suppose we consider POQ and POR. They have same vertex O. Common arm is POPO, but their interiors are not different. If you see, then you find that the interior of POR and interior of POQ are overlapping. So even if they have same vertex, they have one common arm, but not different interiors. So they are not adjacent angles. Okay. Similarly, if you take angle QOR and angle POR, again the same thing happens. When you look at them, they have common vertex O, one common side OQ. The common side is OQ, but their interiors are overlapping because POR is here and QOR is here. So their interiors are overlapping. So no different interiors, and so these are not adjacent angles. But when we take angle QOR and angle POQ, we find that they have common vertex O, common side OQ, and their interiors are distinct like POQ and QOR. So they are termed as adjacent angles. Okay. Now, keeping in mind that three conditions: first, same vertex; second, one common arm; third, different interiors. When we come here, we get that there are four angles and two straight angles. But we are not going to consider straight angles. So AOQ, BOQ, BOP, AOP. These are the angles. Among them, if I consider AOQ and BOQ, then these are adjacent angles. If I consider AOQ and AOP, these are adjacent angles. And we termed as non-adjacent. So with AOQ, AOP can't come, BOQ can't come. So the rest is angle BOP. So angle AOQ and angle BOP are vertically opposite angles. I hope, Arnika, it clears.
But sir, like using our previous definition, you said that two adjacent angles should have like one common angle, one common arm, and different interiors.
Vertex, not angle.
Yes, sir. Sorry. So then,
Hmm.
like using that same definition, won't AOP and QOP be like adjacent by that definition because they do have
Okay.
one common vertex that is
Yeah. And which common side they have?
like AO and OB are common, right? Because they are like on
Ray
the same
OA.
line.
No, 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 no. Ray OA is the side of angle. Ray OB is the side of angle. So they
Oh,
are
okay.
collinear, but they are distinct. Their intersection is only the point O. Got it?
All right. Okay.
Yeah. And it is necessary that two different lines intersect each other. So then only we get the pair of vertically opposite angles. Got it?
Yes, sir.
Yeah. Okay. Yes, Gitanjali.
Sir, I have a doubt in the adjacent angles.
Yes. Ask.
So, in the previous case, the angle POR,
Yeah. Where?
yes,
Yeah.
angle
POR.
POR and angle QOR, they can be considered as adjacent angles, right?
No, no, no. Read this. Read this.
Uh, if the two
Different
angles,
interiors. Are their interiors different? POR and QOR. Are their interiors different? They are overlapping.
so can I consider the exterior angle of POR?
We do not consider the reflex angle, okay? We consider
Okay.
only angle less than 180 degree. That
Okay.
is what we, that is, we do not consider reflex angle in pair. Okay.
Okay.
Yeah, conjugate angles is a different concept where we consider the reflex angle, not here.
Okay.
Yeah. Okay. Yes, Shreya.
Sir, in the definition, would it be better to say distinct interiors rather than different? Because in this case, POR and QR do have different interiors, they just overlap.
Different interiors. That is what distinct. Different and distinct, I think they are synonym. Or they have what is difference between different and distinct?
Distinct would mean that it doesn't overlap anywhere. It's mutually
And different
exclusive.
means also they do not like. When we say different, different is nothing but distinct. I hope so. Okay.
Oh, okay, sir. I thought it was like different. It is different. It just overlaps at one point.
Overlapping means they are sharing some. Like we say that in set theory, we say that the intersection of two sets, that is the common. Okay. And the rest we say that non-common, that is they are different. So we can't say that But intersection, we take the overlapping. Okay. When we say different, that is nothing in common. That is different. Okay.
But usually, so we call two sets different even if one is a subset of the other, or if they have an
Sets, no
intersection.
worry. Say, for example, set 1, 2, 3 and set 3, 4, 5. Okay. So they are overlapping sets because 3 is common in them. But we say that they are distinct sets. They are different sets. Also, we say like that. Okay.
Yes.
Yes. Any more? Yeah. Vivan?
So for the distinct and different argument, different means like, for example, we have a triangle ABC and another triangle XYZ, and they are completely congruent, but they're different triangles because they two are two separate triangles. But distinct means they are like they are completely different. Like one triangle is smaller than the other, and the other triangle is bigger than the other.
Every triangle is congruent to itself. Then we say that triangle ABC is congruent to triangle ABC. Then
Yeah.
do you say that triangle ABC are different triangles here? No. But
No.
when you consider triangle ABC and triangle PQR, PQR has some different position in plane. But they are congruent. Like two angles are equal. Suppose angle ABC and angle PQR somewhere. They are equal in measure 60 degree, 60 degree. Okay. So what we call that, or angles of equilateral triangle, they are 60 degree. All angles are equal.
Yeah.
Okay. So what word we use then? Or what will you use for that? Are they the same if they are equal?
I
They are
think.
different.
Yeah.
Okay.
Okay, sir. Thank you.
Yeah. Okay. Going ahead. This is a typical question now. Angle XOA and angle XOB are angles on the same side of ray OX, and ray OC bisects angle AOB. Okay. Prove that angle XOA plus angle XOB is equal to twice of angle XOC. So ray OX, it is said that angle XOA, this is ray OX, this is our angle XOA, and angle XOB, here is somewhere angle XOB, or otherwise I can draw little bit more, say here. Okay. Not exactly 90 degree, just a minute. Okay. Because it is said that these are the angles on the same side of ray OX. Now it is said that ray OC bisects angle AOB. AOB is bisected by ray OC. So I will draw here. Okay. And now we need to prove what is the desired result. Angle XOA plus angle XOB is twice of angle XOC. Okay. So for this, we have to use the meaning of angle bisecting. So we say that ray OC bisects angle AOB. Therefore, angle AOC equal to angle BOC is equal to half of angle AOB. You can consider these angles as XX also, that doesn't matter. So I am not now using the letters. So that is what the approach we can have. Yes, Kian, what happened?
Sir, in the question paper, it is given that AOX minus XOB. But here it is, but here the question is given plus.
I think you are reading question 6. We are at question 5.
Oh, sorry, sir.
Thank you. So angle AOC and BOC are equal to half of angle AOB because OC, ray OC bisects angle AOB. Okay. One can consider their measures as XX also. So again, now you don't pop up any idea for that. Now, there are many pairs of adjacent angles. Okay, like I am just writing here. This is my rough work, that or scratch work, we can say, like angle XOA and angle AOC are adjacent angles. Angle AOC and angle BOC are adjacent angles. Moreover, angle XOA and angle AOB are adjacent angle. Moreover, angle XOC and angle BOC are adjacent angles. So there are such pairs of adjacent angles. Okay. So XOA is adjacent with AOC or AOB. AOC is adjacent with BOC or XOA. And XOC is adjacent with BOC. Why did I write this? Because we need to analyze the figure. When we have the question, then we need to first of all draw the figure. Then we need to understand the figure. And so we can. Yes, Rakshaya, what happened?
The diagram can be also like XOA are the greater than like.
No, I am not getting clearly. Can you repeat?
Like first you have drawn XOB and above that you have drawn XOB also.
It doesn't matter. Okay. So that doesn't change the meaning of the question. I hope so. Because it is said angle XOA and angle XOB are angles on the same side of ray OX. Okay. So if I take B over here and claiming, then it is wrong. Because then XOB and XOA are at the opposite side of ray OX. Got it? So that doesn't matter whether X goes over here or B comes over here. Okay, so suppose if I am changing, then this would be A and this would be B, but ray OC remain the same because it bisects angle AOB. Okay, I hope you got this.
Yes.
Okay, now we need to resemble some thoughts like XOA and XOB. I am finding where is XOA and where is XOB, and I am finding that I need to reach at twice of angle XOC. Then I need to first of all concentrate on what possible pairs of adjacent angles are there. And because they are adjacent, then we have the angle addition axiom. So for that, XOA plus AOC becomes angle XOC. Okay. Angle AOC plus angle BOC. AOC plus BOC form angle AOB. Angle XOA plus angle AOB form angle XOB. And XOC plus BOC. XOC plus okay, wait. Yeah, BOC. XOC and BOC again form angle XOB. Okay. So we find that there are two ways to express angle XOB as the sum, which we can use here in our LHS. So I consider LHS, which is angle XOA plus angle XOB. Okay. Then we find that while I want to reach at angle XOC and angle XOC is included over here, where I need XOA and I need AOC, and here I got that already XOA is there. So I am not going to change angle XOA. I need to change angle XOB. And in that, I am trying to find out where XOA is included. So I use that this angle XOA as it is, plus this angle XOB I can consider as angle XOA plus angle AOB. Angle XOA plus angle AOB. So for simplicity, I give it as number 1. And here I need to give the reason. As angle XOA and angle AOB are adjacent. Because they are adjacent angles, we apply the angle addition axiom. If two adjacent angles are added, we get the third angle formed by their non-common rays with the same vertex. That is angle addition axiom. Now, because what I marked over here in yellow box, that XOA plus AOC comes. Here I have already twice of XOA, and because of first, angle AOB can be said as twice of angle AOC. This is from 1. This happens from 1. Because angle AOB can be stated as twice of angle AOC, then I can take 2 common to have angle XOA plus angle AOC. Then because of the again angle addition axiom, we have twice of angle XOC. We say that angle XOA and angle AOC are adjacent. And which is our RHS, and it completes the proof. Okay, so there can be different approach. I am not claiming that only this way we can solve. So you can make some different adjustments to get the same result. So for now, what I clicked, I wrote. It is not that only this kind of adjustments we can make. Okay, I hope you got this. Can we go ahead now? Yes. So here we are. Angle AOX.
Excuse me, sir.
Yes. Who is
Can
there
you show the
without
previous
raising
slide?
the hand? Oh, Gitanjali, you need to raise the hand so that I can
Sorry,
identify
sir.
somebody is there. Yes, what happened?
Just wanted the slide, sir.
Okay. Okay. So I request you all that while working, you need to write along with me. I am not faster. Okay. I am right slowly while we are discussing. So I think it is a sufficient time. But even if you are missing, just let me know. But hopefully you can. Yes, Nimal Jivi.
Sir, so am I audible?
Yep.
So in LHS, the second step, he wrote as angle XOA plus angle XOA plus angle AOB. So how did it change to 2 angle AOC?
Good.
Next,
What is the reason? Can you read this reason?
from 1.
Okay. Where is 1?
The, uh,
Here I gave number 1. Can you see?
yeah.
Okay. What is
And
that?
then whole AOB it's equal to 2 AOC.
Correct. So twice O goes over there. We get twice of AOC is angle AOB. Am I right?
Okay, sir.
Got?
Yeah.
Okay. Good. Okay. I hope we got this all. Now going ahead. Okay. Question 6. AOX and XOB are adjacent angles, in which angle AOX is greater than angle XOB, and OC bisects angle AOB. Okay, now we need to take care because AOB angle is formed by the summation of AOX and XOB because they have OX ray common, vertex O common, and distinct or different interiors. So their summation goes angle AOB. Moreover, while sketching the figure, we need to keep this condition in mind that angle AOX is greater than angle XOB. And then we need to use this to prove that. Sorry, not use, we need to prove that. Okay. So we need to draw the figure. So it is said that angle AOX and angle BOX or XOB. So this is AOX and XOB. So AOX and XOB are adjacent angles. Yes, my figure I drew, they are adjacent. Then angle AOX is greater than angle XOB. Yes, look-wise it is, and it should be. Now it is stated that ray OC bisects angle AOB. So ray OC bisects angle AOB. So it is must that because AOX is greater than XOB, then one can take it as equal, then OX and OC will coincide. If AOX and XOB are equal, okay, so if they are not, there is no that greaterness, then ray OC will coincide with ray OX, but it must not because AOX is greater than XOB. Okay, so it is almost like the sixth part, but here again we need to find out the possible pairs of adjacent angles. So already we are known that angle AOX and angle XOB are adjacent, which form angle AOB. Okay. Another case is that angle XOB and angle XOC are again adjacent. You can look in the figure. Where is angle XOB? Where is angle XOC? And they form the adjacent angles. So their summation is angle BOC. Moreover, angle XOC plus angle COA, they form the pair of adjacent angles. So their summation is angle AOX. Moreover, we have angle BOC plus angle COA or AOC, they form angle AOB. Moreover, I think they're that much. Okay. So these are our adjacent angles. So let's check that whether we considered all possible pairs of adjacent angles. With XOB, there is XOC. XOB with XOC, that I wrote. With XOB, there is AOX, that I wrote here. Then with XOC, I have COA, where I wrote this. And then with BOC and COA, they are adjacent. Their summation is angle AOB. So I merely wrote the pairs of adjacent angles. Now I am going to consider the meaning that OC bisects angle AOB, and then I will take the LHS and I will make some adjustments to get some kind of thing to come at twice of angle SOX, or sorry, XOC or COX. Here XOC is nothing but COX. Okay. So just to avoid the confusion, I can write it as COX. That doesn't matter because we do not consider any orientation. So angle COX. Okay. Let's start our work that it is said ray OC bisects angle AOB. So we have angle AOC is equal to angle BOC is half of angle AOB, or twice of AOC, twice of BOC, or I can say that twice of AOC is equal to twice of BOC is angle AOB, and I am giving it as number 1. Just to avoid the confusion, I did this. Okay. Now, what can we do? We will consider the LHS. Oh, sorry. LHS. So LHS is angle AOX minus angle XOB. AOX minus angle XOB. Okay. Now I have some 4 equalities because of the adjacent angles, and I want anyhow the COX in roll. So when COX is there is XOB. When COX is there is AOX. Okay. Then how can I resemble the thought? Okay. So for XOB, I can write it as BOC and BOC minus XOB as BOC minus COX. If I shift this COX on that side, then I get angle XOB as the subtraction or the difference of angle BOC and angle COX. So COX came in play. Okay. Now, while doing the same action with our angle AOX, this AOX can be written as COX plus COA. I will write that AOX as angle COX plus angle COA and minus in bracket XOB as angle BOC minus angle COX. And for that, I should give the reason that angle COX and angle COA are adjacent, and second pair that angle XOB and angle COX are adjacent. So I used 2 pairs of adjacent angles, like angle COX and COA are adjacent, angle AOB and angle XOB and angle COX are adjacent. So we have to open the bracket. I am opening the bracket. I get angle COX plus angle COA minus angle BOC plus angle COX. Now, because of 1 here also you can say this as 1, because both have the same meaning. You find that these two are the same. COA or AOC is equal to BOC. So we can cancel it out. So we get it is equal to twice of angle COX. We can say from 1, angle COA is equal to angle BOC. So they cancelled out, and our LHS is RHS. So it completes the proof. Okay, so what I was thinking, that twice of some angles to be used, that we couldn't, or we didn't have to. So anyhow, we made some adjustments and we got the answer. So these adjustments can be done by considering some measurements in small letters X, Y, Z, P, W, whatever you want. Accordingly, also we can play with the same. This is a simple task that we are dealing with the definition of adjacent angles and angle addition axiom. Because of that, we have such fair results in question 5 and in question 6. Okay. So I think we can go ahead. Okay. So nice. Question 7. If the bisectors of 2 adjacent angles are perpendicular to one another, then prove that those adjacent angles are formed by 2 intersecting straight lines. Or we can say that those adjacent angles are angles in linear pair. So it is a converse. This question is a converse of question 3 or 4 somewhat. I think I just go back. In question 3, we have stated that what is the angle between the bisectors of both angles in linear pair? That angle is 90 degree. That angle is 90 degree. Angle POQ here is 90 degree. Now its converse comes. If the angle between bisectors of two adjacent angles is 90 degree, then we need to show that those angles formed by the straight line, or those are angles in linear pair, that we need to show. We will draw the figure accordingly. Suppose this is a straight line and okay, or otherwise I can say intersecting line, that doesn't matter over here. So line AB, CD, but I don't know whether AOB is a straight line or COD is a straight line or not. Okay, and it is not necessary to consider for both the lines. If I show AOB is a straight line, then we are done. Or if I show that COD is a straight line, then also we are done. Only the thing is that for which two adjacent angles bisectors I am considering. Accordingly, we can. So I need to draw the bisectors. So ray OP bisects angle AOC and ray OQ bisects angle BOC. Okay, so we consider that let angle AOC and angle BOC be two adjacent angles. Then we say that ray OP bisects angle AOC and ray OQ bisects angle BOC with angle POQ is equal to 90 degree. With angle POQ is equal to 90 degree. Then we need to show that, to prove that AOB is a straight line. AOB is a straight line, which implies that angle AOB is 180 degree. Which means angle AOB is 180 degree. That is a straight angle. That is our destination, to prove that angle AOB is a straight line, or angle AOB is 180 degree. What we can do here, we say that, we say that let angle AOC is 2x and angle BOC is 2y. It is convenient to consider their measurements like in short, that is shorthand notation or small letters. Instead of saying AOAC, AOC, I consider it as 2x. Okay. Then ray OP bisects angle AOC. So therefore, from given, we have angle AOP is equal to angle POC is x and angle BOQ is equal to angle QOC as y. Moreover, we have as angle AOC and angle BOC are adjacent. Therefore, I say that angle AOC plus angle BOC is angle AOB. Here we use the angle addition axiom, that angle AOC plus angle BOC is angle AOB, but AOC is 2x and BOC is 2y, which is our angle AOB. I give it as number 1. Okay. I give it as number 1. So we have now angle POQ is 90 degree, but POQ can be stated as angle POC plus angle QOC is equal to angle POQ. So we have the statement that angle POC plus angle QOC is angle POQ, and therefore we have x plus y is equal to 90 degree because POC is x and QOC is y. Then we multiply by 2, multiplying both sides by 2. We multiply both sides by 2, and so we have twice of x plus 2 times y is equal to 180 degree. Then from 1, twice of x plus twice of y is angle AOB, which is 180 degree, and it completes our proof. Okay. So in this way, we can deal with the final conclusion. These are some kind of, it is our start. So I am giving you the correct ideas and also the way how we need to write the solution. I know that when we solve many questions, then we ignore some writing part, but sometimes that ignorance may lead to some misunderstanding. So initially, I always request all that, yeah, you need to write the solution in proper manner. Okay. Now we are going to turn our attention towards the next sheet, that is here. Some questions are put over here, but I think before that, yes, Krishna.
Sir, can you just go to the previous slide?
Yes, I got. You wanted that. Okay. So, yeah, over, Krishna.
Yes, sir. Thank you, sir.
Okay, welcome. Yeah, going ahead. There are questions I put in the next worksheet you might have received. Here are the questions. And I included those questions in my slides. But before that, we need to talk about some concepts, some typical things, few theorems, and then we will turn our attention towards solving the problems. Meanwhile, you will get the time period of 1 week. During that time, you can discuss the questions with your friends, or you can attempt those questions. And next time, we will see their solutions, not necessarily of all, but of few, so that we can save the time. But before this, I need to create some background of that. And here I put all the questions. Okay, so here till 10, all questions are included. But I am just keeping those questions aside, and now we will go ahead with some typical part. Okay, some kind of theorems related or required for our concepts. See, we know that there is some kind of congruence of some triangles or some figures. Then first question or very basic question comes in our mind, that what do we mean by congruences? Okay, congruence means what? When we ask the question about congruence, then it is clear that when there is exactly superimposing figures, okay, when there are some superimposing figures, then we say that there is congruence. Okay, and because of that, we have so many good ideas in our mind. And actually, according to the theoretical background, we need to consider first similarity, then congruence. But uh, as per the development of our mind, we need to first consider the congruence and then we go for the similarities. Okay. There are some typical kind of the theorems which we need to do. I am not going to take the proof of each and every theorem because some proofs are typical, more theoretical. So I will keep the proofs aside, but we will have a small idea of congruences. So first of all, we need to see what is mean by the congruence of triangles. When we say congruence, then we need to say the exact overlapping, superimposing, or we can say that when I suppose, for example, here is my scratch work. If I have triangle and I have another triangle here, suppose this is triangle ABC and say this is triangle PQR. Then uh, I drew these triangles by taking a little care that those two triangles are exactly same, looking wise same, suppose, but the orientations are different. Suppose I have some machinery and I flip this triangle PQR to ABC, or I flip ABC to PQR and I allow them to superimpose each other. Then there are variety of ways that we can superimpose, but exactly vertex to vertex, side to side uh, can't be superimposed. Then there is exactly one way in which we can superimpose to them. Yes, Ritvik?
Sir, is it RHS?
Huh?
RHS, right hypotenuse side, basically.
What is that? I don't know.
So basically, the hypotenuse is same of AC and QP, so.
What do you mean by hypotenuse? I am not sure about hypotenuse. Can you tell me? What do you mean by hypotenuse? Ritvik.
Sir, I don't know, sir.
Okay, if you don't know hypotenuse, how can we use what is hypotenuse? Okay, yes, Kian.
Sir, hypotenuse is the longest side of a triangle, no?
Oh, I
Especially
don't know. No, I don't.
right
You need to
triangle.
tell. You need to
Especially
tell.
a right angle triangle, the longest side.
No, but if you say that the longest side of a triangle and the longest side of a right angle triangle, then there is a difference. What do you mean? You mean only of a triangle or a special triangle?
Only for triangle, but we mostly use the
No, no,
hypotenuse
no.
right angle triangles.
Oh, I think you are dilemmatic a little bit, but it's okay. Yes, yes. If I'm not wrong, Lashia, am I right?
Yeah, you're right.
Okay, yeah.
Hypotenuse is the longest side of a right angle triangle.
Yes, hypotenuse is the longest side, or we can say that the side opposite to the right angle of the triangle. That is what our hypotenuse. So I think I am not in any special case. What I am talking, you try to listen. I am just saying that these two triangles seem to be exactly same. I drew them by hand, and so I didn't take care about exact measurements. Okay. Moreover, I didn't maintain the same orientation. So they are flipped, little bit tilted. But suppose they are exactly the same, then we can superimpose them in one way. While superimposing, we come to know that the vertex A goes with P, the vertex B goes with vertex R, and vertex C goes with vertex Q. So A is to P, B is to R, and C is to Q. We call that this is nothing but one-to-one correspondence. One-to-one correspondence. Okay, so this is one-to-one correspondence. And if I say that side AB is PR, side BC is RQ, and side AC is PQ. Moreover, angle ABC is angle PRQ, and angle ACB is equal to angle PQR, and angle CAB is equal to angle QPR. If these whole 6 things are correct, then we say that yes, those triangles are superimposing each other. When we say that superimposing, then geometrically we say that those triangles are congruent, and we claim that triangle ABC is congruent to triangle PRQ. While writing such name, what I just make the yellow box over there, while writing the names, those names should occur in one-to-one correspondence. And one-to-one correspondence goes just because of the equality of their elements. A triangle has 6 elements, which are basic or fundamental elements of it, namely 3 sides and 3 angles. So when we say that, okay, when we say that all 3 sides of one triangle are equal to all 3 sides of the other triangle, and all 3 angles of first triangle are correspondingly equal to all 3 angles of the other triangle, then those two triangles are congruent. Okay, so what I say that if all 3 sides of of first triangle are correspondingly equal to all 3 sides of the second triangle, and all 3 angles of first triangle are correspondingly equal to all 3 angles of the second triangle then those two triangles are congruent in that one-to-one correspondence. The language we use is little bit longer but necessary. So when two triangles are congruent, that if all 3 sides of first and all 3 angles of first are correspondingly equal to all 3 sides and all 3 angles of the second, then those two triangles are congruent in that one-to-one correspondence. One-to-one correspondence has importance. Okay, and its converse is that. So conversely, we can say, if two triangles are congruent in given one-to-one correspondence, then their corresponding sides are equal and corresponding angles are equal. When we talk about congruence of two triangles, then basically first we consider their six elements, namely three sides and three angles. Okay, we consider their six elements, that is three sides and three angles. So two triangles, when are they congruent? When they're all three sides and all three angles are correspondingly equal. But while proving any two triangles to be congruent, we have some typical tests or theorem. In our regular school studies, we term them as tests. And according to the development or the foundation of geometry, among those tests, side angle side congruence is considered as the axiom or definition here. And using that, we can prove the others, like the side congruence test or angle congruence test. We can prove by using side test. So those are the theorems. Moreover, there is a special test called as the right angle, hypotenuse, and side test, which is mainly for two right angle triangles to show them congruent. So we are not going to consider the proofs of those things, and we are not going to more rigor in that aspect. Just I am telling you orally, and we will go ahead. Okay. So we can say that the equality of, yes, Nimal.
Sir, is there any reason that you put correspondence symbol for the points and equality symbol for the sides and angles?
Yeah, this arrow shows one-to-one correspondence. A and P are corresponding to each other. That is one-to-one correspondence. B and R are one corresponding to each other. That is, there is one-to-one correspondence between B and R. So this is the arrow symbol for showing one-to-one correspondence. Okay.
So what is the difference between one-to-one correspondence and normal correspondence?
See, like for example, in this figure, what I had drawn the figure at the right corner. If I say, I'm writing here that triangle ABC is congruent to triangle PQR, then it means that AB is equal to PQ. Is AB equal to PQ in this figure?
Yeah, no.
No. Why not? Because A is with P, it's okay, but B is not with Q. And so AB and PQ can't be the corresponding sides.
Yeah.
Did you get?
Yeah.
Okay. So one-to-one correspondence has importance. If there is no one-to-one correspondence, then it would be vague. We can't tell exactly what is going on. Got it?
Okay, sir. Yes, sir.
I hope I answered your doubt. Okay.
Yes, sir.
Yeah.
Yes,
And because of that, I intentionally changed the orientation. Okay. About the naming. Because if I went alphabetical order, then it is but obvious. Yes, Gitanjali.
Sir, all corresponding triangles are superimposing always.
Sorry, corresponding. No,
Yeah.
congruent. Congruent.
Sorry, congruent.
Congruent, that is superimposing. Isometric. Exactly, they are superimposing.
So corresponding triangles?
No. Where I said corresponding triangles.
The sir, nothing, sir.
Wait. No. I might have made any mistake. Is there any mistake in my writing?
No, sir.
No, I think not. No. It's okay. Yeah, those words sound almost equivalent. Congruence and correspondence. So many times we jumbled up. Yeah. Okay. So I think this is little bit important to have the one-to-one correspondence. So I would like to suggest you that instead of solving any kind of non-routine way of problems, non-routine means here which are beyond our syllabus. I call them as non-routine. So I would like to suggest you that if you solve our 9-10 standard geometry textbook of NCRT, say, or Maharashtra State Board, those are available online, so you can download them. So I am from Maharashtra, so I can tell you that I know the Maharashtra State Board book is better to clear small concepts about congruence and similarity, circles. So if you solve them at your own, it will support you a lot to understand the non-routine problems. Again, I state what we mean by non-routine. That is such questions which do not contain any restriction of the syllabus, or such questions are not meant for any kind of board like ICSC or CBSC or IB, IG, any board. Okay. So here we mean that if you solve that book, and if you face any problem, you can ask me through the mail. I am ready to clear your doubts. Okay. And here I am just giving you the rough sketch or idea about the theory, but I am not going to prove the theorems rigorously, because number one, it will take more time. Number two, it is little bit boring. So we are going to avoid that. Okay. Coming to the point. The equality of three corresponding sides and three corresponding angles of two triangles. So the equality of three corresponding sides and three corresponding angles. Okay. So that is nothing but equality of six corresponding elements. Now one may have a question that is an altitude an element? Then I think we mean element that is only angles and sides. Altitude, median, internal angle bisector, external angle bisector, or like perpendicular bisector of the side are the next elements of the triangle. So we may consider them afterwards. Here I say equality of six corresponding elements. That is what three corresponding sides and three corresponding angles of two triangles. So equality of six corresponding elements are necessary conditions for congruence of two triangles. So equality of six corresponding elements are necessary conditions. So in short, there are six necessary conditions. Then among these six necessary conditions for congruence of two triangles. Among these six necessary conditions for congruence of two triangles, comma, three specific conditions are true, then also those two triangles would be congruent. Then also those two triangles would be congruent. So among these six necessary conditions, so there are overall six necessary conditions. Which are they? Namely, equality of three corresponding sides and equality of three corresponding angles of two triangles. So among these six necessary conditions, if some specific three conditions are true, then also those two triangles would be congruent. And we call such specific conditions. So these specific conditions, we term them as the tests for congruence. According to our textbooks, language of textbook I am using. So these are the tests for congruence of two triangles. According to the theoretical background, one is axiom, others are the theorems. But we are not going to prove them. So I use at the name tests, and those tests are namely like SS. We say this is the axiomatic, that
Side
SS
angle
side angle.
side.
Huh?
Ma'am, so side angle side basically.
Wait, don't take more time, because yeah, you know that it's very good. Then another is that side. Then third one is angle side angle, or it is also termed as angle side or side angle. And a special test comes, that is nothing but RHS, which is specially for a right angle triangle. Okay, so why tests are necessary? Because it is clear that when we need to show the congruence, actually we need to go for 6 corresponding elements equality, then it is ridiculous. But among these 6 necessary conditions, some specific conditions are there. Those specific conditions, we call them as actually sufficient conditions. These conditions, we call them as sufficient conditions. And when these sufficient conditions are true, even if those triangles would be congruent. And we term, according to our textbook language of any board, we call them as tests. But here, theoretically, our side angle side test is axiom, and rest are the theorems which we can prove. Okay. Okay, this is side. That is my writing mistake. Thank you. I came to know that. Sorry for it. This is side. Actually, I wanted to say that this won't be the test. Side A, SSA is not the test. Okay. So now in next period, we will go ahead with our work about the congruence. We will acquaint with more things and few theorems related with that. Moreover, meanwhile, I had given you some problems and hoping that you may solve those questions. Yes, Ritvik, what you want to say?
Sir, I had learned this in 7th standard, sir. Learned this in 7th standard basically.
Matter. See, grade or standard, that doesn't matter. If you are able to read and understand, you can do anything. Okay, good.
Yes, sir.
Yes, Gitanjali.
Sir, basically, it's side angle side means there are two sides for both the congruent triangles. They both have both of their two sides are similar to each other. Two sides and one angle is similar to each other, and side means all three sides of both the triangles are similar to each other.
Wait, similar word is not correct there. And first thing is that triangles are not congruent. Triangles are congruent if SAS happens. Okay. Two sides and their included angle. We will discuss that in our next session because it takes more time. And moreover, sides can't be said as similar. Sides are equal, or we can say congruent. Okay.
Congruent.
Yeah. Okay. Yes, Vivan.
Won't won't RHS be same as SAS?
No, RHS is specially for right angle triangle, because if there are two right angle triangles, then right angle equality is but obvious. And if the side opposite to right angle, which is termed as hypotenuse, so for those two triangles, if their hypotenuse are equal, and other than hypotenuse, the second corresponding side, also those two sides are equal, then those two right angle triangles would be congruent. We will see actually these in detail. I just gave the names now. Okay. Yes, Arnika.
Sir, in the third criteria of like the congruence test, you said that it will be ASA or AAS, but they're both distinct, right?
Yeah, they are the same, because in a triangle, the angle sum property is the fixed invariant. And so if two angles are equal, automatically third angle is equal. Okay.
Okay, sir.
So we have angle side angle or angle angle side, the same. Okay, so I think for today it is more than sufficient. So let's see next time. Till then, bye bye. Thank you and see you.
Thank you,
Yes,
sir.
sir. Bye.